All right, so we've got some more examples to work through. In this case, we're going to start with log of x cubed minus 8 minus log of x minus 2. So we're going to look at that and we're going to say, oh, I got a difference of logs. I can apply the quotient rule. Right, quotient rule. But then we look a little suspicious at this because x cubed minus 8, that's a difference of cubes. And I feel like it can be factored, right? And you may remember the formula for factoring this, but if you're like me, you have no clue. So you're just going to say, well, I think I have a suspicion it's divisible by x minus 2. So let's look at that. Let's see, cubed, squared, x, and the constant form, constant. So 2, 8, oh wait, 2, 4, hold on. I was getting ahead of myself here, right? 2 times 2 is 4, plus 0 is 4, 2 times 4 is 8. So it is divisible by that. So if we simplify the expression, we've got x squared plus 2x plus 4, because we canceled the x minus 2's basically. Now, you do need to be careful here because the original function, remember that we have an asymptote at x equals 0, right? So for log of x, so has asymptote at x equals 0, right? So in other words, log of 0 is undefined. If you ask your calculator, it will say undefined or just give you an error, give you nothing, right? So this expression, the unsimplified version, we cannot plug in 2, first off, because that's going to give us 0 over 0, and log of 0 or undefined is still undefined. So here, we put a little note here that if this were in an equation all, we can't allow x to be equal to 2. Other than that, I think we're okay so long as x stays, so long as the expression stays positive. So what about the next problem on here? We've got log base 3 of x plus a half log base 3 of y. So remember, so when we're combining these, our bases have to be the same. You can't combine logs if they don't have the same base. So that's first. Second, before we can use product rule on this, we need to use power rule. So we've got log base 3 of x plus log base 3 of y to the 1/2. So that's power rule. And then we're going to say, oh, I've got a sum of logs. I can use product rule, x times y to the 1/2, or if you like to write that as x times square root of y, it's all good. Okay, so get some more examples to keep going, right? All right, so this one looks super scary, right? It's involved, it's crazy. Okay, but we're gonna follow PEMDAS. We're gonna work inside our parentheses first, right? So we're gonna say, okay, great, this is ln. I got a difference of logs, so ln numerator is the first one, denominator is the second, right? Now we're going to notice, though, I got a difference of squares, so I got x minus 3, x plus 3 over x plus 3. So this actually reduces, right? We're going to get ln just of x minus 3 for that initial part of our expression. But we do want to put a little note here. We don't want to let x be negative 3. And we also need to figure out, are there any values of x that are going to make this whole thing negative? I have no idea. It doesn't matter because this is just an expression, right? So that was quotient rule. To simplify that, and now we're going to say, oh, but we've got a 2/3 multiplying all of that. So we're going to say, okay, great. We've got ln of x minus 3, and we're going to take that 2/3, and where's it going to go? it's going to go back in the exponent. And then we've got plus ln x plus y. Okay, so now we have a sum of two logs, right? So let's see, so this was product rule. Sorry, power rule. Gotta call them the right things. And so next we say, okay, I've got a log plus a log, so we can, in fact, I don't like blue for this. We're going to go back to red. So we'll have log ln rather, x minus 3 to the 2/3 times x plus y. And we're going to have to leave it there. You cannot do anything across addition inside a log, nothing. So this is just product rule, and we're done. Okay, so I've got one last example to work. It's from the web work homework. It's a version of one in the web work homework. We're going to put it in its own video.